I'm Patricia Vahle. I'm a professor of physics here at William & Mary. I am the co-spokesperson of the NOVA neutrino experiment. It's an experiment based at Fermilab, the accelerator lab outside of Chicago. We make a beam of neutrinos at Fermilab, and then we fire them through the Earth to two different detectors. One detector is on site at Fermilab, sort of the control of our experiment. And then we have another, much larger detector up in northern Minnesota, Ash River, Minnesota, about 500 miles away, where we can record the interactions of neutrinos after they've traveled a great distance. So a neutrino is one of the fundamental particles of the universe. It can't be broken up into anything else, and it's one of the most abundant particles in the universe. But the neutrino is kind of a cool little particle because it only interacts very weakly. That means it can travel through astronomical amounts of material without interacting at all. It makes them a little bit hard to study because they don't interact in your detector very often, but every once in a while we do get lucky and we can observe the interactions of the neutrinos in our detector. We are looking for a phenomenon called neutrino oscillations. We make a beam of muon-type neutrinos, but somehow along the way that beam of muon neutrinos changes into other type neutrinos. And we're looking for the muon neutrinos to change into electron-type neutrinos. The key part of our experiment is to compare the rate of this transition between neutrinos and their antimatter particle antineutrinos. And it's in this comparison that we learn new interesting things about the neutrino and how they might affect the evolution of the universe or even the existence of the universe in the first place. In order to collect enough data that we can say something interesting about neutrinos, we have to take a long time. We are planning to run this experiment until at least 2024. So next 5 years, we will be running the NOVA experiment, collecting more data and analyzing that data, looking to see what we can say about neutrino oscillations.